Question 4.5. A smaller circle centered at N is transformed such that point C is translated along the tangent to D. Calculate the coordinates of E, the new center of the smaller circle. So ideally our circle would look something like this, where our tangent is only at D, and we would have a new center E, and that's what we need to figure out. So firstly, what we need to understand here is, well, we know we can actually figure out the coordinates of D. That's the first step from our equation of y is equals to x plus 3, and that is the x-intercept. So D is minus 3 and 0. And what we need to transform now is we need to transform from C all the way to D. So it will be translated or transformed along that specific line. So firstly, we need to move our circle from C to N. All right. So we know the coordinates of C. Let's just go ahead and put that in there. That's minus 1 and 2. We have N, we have D as well. Let's put it there so we have it. And from C to N, we can see that the distance is to add half. So we're going from here to here. We are adding half to x. So here, if we just have x and y, and to get from C to N, we need to add half to x, and we need to subtract half from y. Then thereafter, we need to get from D to E. So D to E, and that transformation now becomes where what we are initially doing to E is we're taking E and we are adding this translation for our from C to N, since it will be exactly the same distance because it's still a tangent. That specific same line is still a tangent. So what's only changing is the actual center. So therefore, what we can do to C is we can take the x we can take the x value of D, and we can have that add the same x value and subtract the same y value as we did for C to N, minus 0.5. So ideally what would happen is E is we take minus 3 plus 0.5, you get minus 2.5, and y we need to subtract 0.5, so we will just get minus 0.5, and that is E. And the reason for that is the distance from here to here, from D to E, will give you the same distance from C to